Hey pre-calculus students, this is lesson 9. Um, in our last lesson, lesson 8, we talked about dividing complex numbers, and now we're going to start to move away from that and look at some geometric effects of our arithmetic. Remember back in lesson 5, we learned how to add, subtract, and multiply. Throughout the rest of this unit, we're going to talk about what these things like addition, subtraction, multiplication, and division, what they look like geometrically, that is, in a picture. All right. So reminder, have your binder with you, take some notes on this as we go through, and then once you've completed everything and watched the whole video, come in and take your exit ticket to get your credit. All right. So let's look at our opening exercise here. Taking the conjugate of a complex number corresponds to reflecting a number about the real axis. We found that out in our last lesson. We were learning about the conjugate. What operation takes a complex number and makes a reflection across the imaginary axis? So I'm just going to make a quick sketch of an axis here. I know if I have some number z, right up here, we found out that if we took its conjugate, if I found z with the little hat on it, or if my z is a plus bi, my z conjugate was a minus bi. If I took its conjugate, it gave me a reflection over the real axis that kind of flip from top to bottom like that. Although this is now asking us to find what would happen to get it to go across the imaginary axis the other way. So once we have the picture, it actually makes a lot of sense. Looking at that z prime, I'm going to call it z prime after we've transformed it. It just needs to have, let's see what changed. The imaginary part, the vertical part, didn't change at all. It's still the same distance up that it was. The only thing that's changed is the real part has gone from positive to negative. So just as like with our conjugate, the imaginary part changing sign made a reflection over the horizontal axis. Here, the real part changing sign, negative a plus bi, will make a reflection over the imaginary axis. So this is one way to write it. We could write it as negative a plus bi, or kind of another fun way to write it is if our conjugate of z equals a minus bi, and we want to get to negative a plus bi, we can just make our conjugate negative. That is, we could take the negative conjugate of z, which would be negative a minus bi, distribute our negative, and you'll get negative a plus bi. So however you want to look at it, as the negative conjugate or just making the real part negative, either one is fine. All right, so in this lesson, there's basically going to be two things we're looking at. First, we're looking at what happens to complex numbers in a graph when we add or subtract real numbers to them. That's what we're doing in this first one. We want to describe the geometric effect of that, adding and subtracting those real numbers. In 4 and 5 on the next page, it's going to have us graph the result of adding and subtracting some complex numbers or some imaginary numbers, and then describing that geometric effect. So our goal is to see what happens when we add real numbers, what happens when we add imaginary numbers, and then kind of get an overall understanding about what's happening. So I would recommend at this point, this is a pretty straightforward lesson, if you could pause the video and then just go on and plot these really quick and then get an idea of what's happening. And then as you come back in, you can kind of check as I go through them really quickly to make sure your plot matches what I got. All right, so hopefully pause it, try these out. They're really straightforward to graph once we get going at it. So I'm going to start over here. All right, so w is negative 4 plus 3i, negative 4i plus 3i. W is going to be right there. Z is 2 minus 5i. We don't have enough space here. I'm going to relabel my axes. I'm going to make this negative 4 here, negative 2, 2, 4, negative 2i, negative Okay, here we go. Negative 4 plus 3i would be right here is my w. 2 minus 5i would be right down here is my z. And then this one's w plus 2, or negative 4 plus 3i plus 2, which would just be negative 2 plus 3i. And then z plus 2, well, I'm only going to change the real part. It's going to be 2 minus 5i plus 2. That's going to be 4 minus 5i. Use some colors here. And that'll be green for this one. So it looks like as I'm plotting these, it looks like as I plotted the plus 2's, it seems like they both shifted to the right. Let's see if it happens. I would kind of expect then that subtracting a number might shift it left. Let's check. If I do w minus 1, that's just going to be negative 5 plus 3i. And z minus 1 is going to be 1 minus 5i. Yep, negative 5, that would be w minus 1, and then z minus 1 will be there. Yeah, so it looks to me like as I added the real numbers in red, I added 2. It looks like my points moved to the right 2, w moved to the right 2, z moved to the right 2. As I subtracted, it moved to the left 1. So describe in your words a geometric effect. Again, when we're talking about geometric effects, it's either going to be a rotation, a dilation, translation, those sort of geometry things we talked about. The one we need here is just a translation. So this is a translation. And I would say specifically this was horizontally. Or maybe left / right. Alright, that's just a brief summary. Let's check out the next one. I'm going to spend less time plotting these. I'm just going to go use the same scale. Negative 4 plus 3i and 2 minus 5i. Now this time we're adding one imaginary number to each. Well, w, if it had an imaginary part of 3i and I add 1 to it, it's going to go up to 4i. So w plus I goes up. Z plus I is going to do the same thing. And then w minus 2i's 1, 2, w minus 2i, and z minus 2i is just going to be down there. So same thing here, we're seeing a shift. As we added an imaginary part, it went up. As we subtracted an imaginary part, it went down. So again, I'm going to call this a translation vertically. And then if we want to be more specific, we would say adding translates. You can also say shifts up, subtracting shifts down. So just really brief notes for us to kind of get a feel. Now, this last thing we need to talk about on this one is we're going to start talking about complex numbers as transformations of these points. So the way we're going to do that is we're going to have this thing called the transformation of z, and that'll be our notation. This is this t, this transformation of z. It could be other letters. It could be like L of z or f of z, any kind of thing. And then the parentheses means it's taking in a number z, and then it'll do something to it. So here's a way we could define a transformation. T of z is equal to z plus, I'm just going to give us one, negative 2 plus 3i. So this transformation is saying take some number z into our transformation. Now what the transformation does to it, it just adds this complex number, negative 2 plus 3i. Or you could think of it, it subtracts 2 real numbers and adds 3 imaginary numbers. We're not really using this example, sorry. What we want to take away from this lesson is to be able to describe what this transformation would do geometrically. So if I draw a picture, I imagine I take in some point. I'm going to take, for example, let's go t of, the real number 2. Let's just do 2. T of 2, well, that's just going to be 2 plus -2 plus 3i. I can do this out algebraically. The 2 and -2 combine to 0 plus 3i. So it looks like our point 2 originally, 1, 2, be right here. This transformation, it transformed it to point 0 plus 3i, right up here, t of 2. So what this transformation did is it shifted it, because we know that adding a real part shifts our thing left and right. It shifted it 1, 2 units to the left, and it shifted it up 1, 2, 3 units. So this example is just meant to get us familiar with this idea of transformation notation. Like, it'll look like this when we have a function or a transformation t that takes in some number z. And then we know that adding and subtracting real and imaginary parts corresponds to shifting left and right and up and down from our exploration today. So overall, I would say the geometric effect of this transformation, which again was adding 2 or subtracting 2 and adding 3 imaginary parts, was a shift left 2 units and up 3 units. So altogether, let's look at our summary for today. Take a second and make sure you have this example with the notation in. Feel free to pause if you need to. But let's look at the lesson summary. So conjugate, we talked about, reflects the point across the real axis. We saw that in lesson 8. The negative conjugate reflects it across the imaginary axis. So again, I'll make a little sketch to help support our thinking. So here's our z. Its conjugate reflects it this way, so that would be the conjugate of z with the hat. Its negative conjugate reflects it this way, negative conjugate reflects across the vertical axis, or the imaginary axis. And then adding and subtracting a real number shifts the point left or right. We saw that. Adding and subtracting an imaginary number, like I or 3i, shifts the point up or down. Perfect. So now that we've done this video, stop on by and take your exit ticket if you haven't already, to make sure you have all your credit made up.